In this lesson, we're going to be looking at something we call the power of monomials, and I'm going to show you what that means. But first, let's review some of the lessons we've had previously. We were learning to write numbers in scientific notation. So I'm going to let you look at 34 million. Can you remember how to write that in scientific notation? Remember, we want the number to be between 1 and 10, which means we want the decimal after the first non-zero digit. Right now it's at the end, so we have to think about how many places we're moving the decimal. There's 3, there's 6, and one more is 7. So if we take away all the zeros here, we would have 3 4/10 times 10 to the 7th. This time it's a decimal, so it's going to be a negative exponent. Again, look at it for just a minute and see if you can think about it. We want to have the decimal between the 5 and the 6. That makes the number 5 6/10, and that number's between 1 and 10. We have to move the decimal 1, 2, 3, 4 places. So that's going to be 5 6/10 times 10 to the negative 4th power. Do the opposite. If we have 6 7/800 times 10 to the 5th power, that means we're multiplying times 10 5 times. And every time we multiply times 5, we are moving the decimal over one place. So we have to move it over 2 right here. That means we have to add 3 more zeros. So it would be 678,000. Here was the decimal. 1, 2, 3, 4, 5. 3 21/100 times 10 to the negative 3rd power. This time it's a negative exponent, so we need to move the decimal to the left to make it a decimal. Here's the first movement. We have to move it 2 more places. So we will add 2 zeros out in front. 0.00321. Now, this idea of power of monomials, power of powers. Today, we are going to be looking at having something, a base raised to an exponent, and then that entire thing being raised to another exponent. So exponents are called power. So this is power of powers, which means an exponent raised to an exponent. So again, when you're taking your notes today, please write down these mental steps, or it's not going to help you remember how this works. When you have 4 squared multiplied times itself 5 times, what you really have is 4 squared times 4 squared times 4 squared times 4 squared times 4 squared. Well, what is 4 squared? 4 squared for each one is 4 times 4. So let's look and see how many 4s, how many times we have the factor 4 being multiplied times itself. 2, 4, 6, 8, 10. We get the exponent of 10. Notice what happens here. 2 exponent raised to the 5th exponent to the 3rd power, or 5th power, 2 raised to the 5th. All you had to do was multiply the exponents. So when we have power of powers, we are going to multiply the exponents. Let's look at another example. When you have 9 to the 6th raised to the 2nd power, you have 9 to the 6th twice, being multiplied times itself twice. So you have 9 6 times this right here, 9 to the 6th power. Here is 9 to the 6th power again. So how many times is the factor 9 being multiplied times itself? Well, that would be 12. All we had to do was multiply the exponents. Power of powers, an exponent raised to another exponent. Q to the 4th power raised to the 3rd power. Hopefully you can get so that you can look at these and automatically know, ooh, power raised to a power, power of powers, I multiply them, and that would be Q to the 12th power. But for our notes, well, this one's not on your notes, so you don't have to worry about writing this down. But here's what it means. You have Q to the 4th power 3 times. So here's Q to the 4th, Q to the 4th, Q to the 4th, which makes 12 of them all together. You try it here. What do you think this would be? Think mentally. 4 cubed raised to the 2nd power, or 4 cubed squared, would be 4 to the 6th power, because you have to multiply 4 times itself 6 times. M squared raised to the 5th power, think about it. It would be m to the 10th power. This time it's a negative exponent. And we had a lesson about negative exponents. In our final answer, we can never have a negative exponent. So the first thing we're going to do is multiply this. Okay, because it's negative, this has to go downstairs to the denominator. Remember us doing that? So what you have here first is you multiply the exponents. 4 times negative 3 is a negative 12. But we can't stop there because we cannot finish with a negative exponent. So do you remember us talking about how we have to move it downstairs? If it's upstairs, move it downstairs. If it's downstairs, move it upstairs from the numerator to the denominator or the denominator to the numerator. So all we do is move that downstairs. And when you do that, instead of a negative exponent, you now have a positive exponent. So our final answer would be 1 divided by 3 to the 12th power. You could evaluate this with your calculator. You could do 3 raised to the 12th power. I don't know what that number is, but you could put that under 1. Look at another example. Okay. If you have more than one base in the parentheses, notice in this set of parentheses we have two bases. We have a base of 2 with the exponent of an invisible 1. We have the exponent of x raised to the 3rd power. The exponent on the outside has to be applied to both of them. So first you think 2 to the 1st power raised to the 5th power. Then you're going to think x cubed raised to the 5th power. You have to do it to both of them. Well, we've learned when a power is raised to a power, an exponent raised to an exponent, we multiply. So here 1 times 5 would be 5, so that would be 2 to the 5th power. Here 3 times 5 is 15, so that would be x to the 15th power. We're not going to stop there, because when evaluating, we're going to go ahead and evaluate if the coefficient or if the base is a number and not a variable. We can go ahead and evaluate this. So with your calculator, you can do 2 raised to the 5th power and find out what that number would be. Here it is all written out. I'm going to erase this. This just shows you what you're doing. You're multiplying 2 times itself 5 times. Whoa, go away. Let's see if we can get that to go away. And then we have x cubed 5 times. So that would be 32x to the 15th power. This time we have 3 bases. We have a base of 4 raised to the 1st power. So we have 4 to the 1st power raised to the 2nd power. We have a base of m squared raised to the 2nd power. And we have n raised to the 2nd power. So the exponent has to be for each base. So if we think about that, we just look up here, we say 4 raised to the 1st power, 2nd power. What's 1 times 2 is 2, so that'd be 4 to the 2nd power. Here we have 2 times 2, so that'd be m to the 4th power. And then we have 1 times 2, so that's n squared. Again, we can go ahead and evaluate this. And 4 squared is 16, so our final answer would be 16 m to the 4th n squared. I'm going to erase this because the PowerPoint's going to pull it up anyway. There's what we have. 16 m to the 4th n squared. So here was 4 squared. Here was m squared twice. And here was n raised to the 2nd power. Let's try another one. We have 2 bases inside this parentheses. So we have 5. It has to be squared. So the first thing we do is we're taking 5 and we're squaring it, which is 5 times 5. Then we have r to the negative 7th power raised to the 2nd power. Remember, we're multiplying with exponents. So that would be a negative 14. Remember, we cannot end with a negative number. So here is our 5 squared that we had. There's our r to the negative 7th power twice. That gives us 25 times r to the negative 14th power. We have to get rid of the negative exponent by moving this base downstairs. When we move it downstairs, it becomes a positive exponent. So our final answer would be 25 on the top, it did not move, divided by r to the 14th power. r to the 6th raised to the negative 2nd power. First we're going to multiply 6 times negative 2, which is a negative 12. We cannot end, or we're not finished until we get rid of negative exponents, so we have to move it downstairs, and it would become a positive exponent. 1 divided by r to the 12th power. Here we have 3 bases. So we have negative 2 to the 7th power. We have f cubed raised to the 7th power. And we have g to the 4th raised to the 7th power. The exponent has to be applied to each base. That's going to give us negative 2 to the 7th power. Here we're going to have f to the 21st power when we multiply. And here we're going to have g to the 28th power when we multiply. And negative 2 to the 7th power, when we type that into our calculator, you would have a negative 128. And there's our f to the 21st and g to the 28th. Okay, so remember, when you're doing power of powers, you're going to multiply the exponents. And if there are more than one base inside the parentheses, make sure you apply it to each of the bases. And that ought to get you. Good luck.